Here we go with section 2.3, Biconditionals and Definitions. The objective today is to write biconditionals and recognize good definitions. A biconditional is a single true statement that combines a true conditional and its true converse. It can be written using if and only if. So here's kind of your keywords that you're looking for. I abbreviate this as IFF. It kind of looks like you're spelling the word if wrong, but it stands for if and only if. Problem 1. What is the converse of the following true conditional? If the converse is also true, rewrite the statements as a biconditional. If the sum of the measures of two angles is 180, then the two angles are supplementary. So to write the converse, we have to figure out what is the hypothesis, what is the conclusion, and then switch them around. So the hypothesis is the sum of the measures of the two angles is 180. The conclusion is the two angles are supplementary. So the converse is, what do you get when you switch them around? So if the two angles are supplementary, then the sum of the measures of two angles is 180. So before you actually write it as a biconditional, you have to determine if both conditionals are true. So if the sum of the measures of two angles is 180, then the two angles is supplementary. This one is true. If the two angles are supplementary, then the sum of the measures of the two angles is 180. This is also true. So if both are true, you can write it as a biconditional. You can use either one to do this. I'm going to cross off the if, cross off the then, and you're going to replace the then with if and only if. So the sum of the measures of two angles is 180 if and only if the two angles are supplementary. Now, this can also be written from the converse. It doesn't matter which one you pick as long as you're canceling out the right words and putting if and only if in the middle. All definitions can be rewritten as biconditionals. So here's another one. If two angles have equal measure, then the angles are congruent. So again, we have to identify the hypothesis and the conclusion. Hypothesis is two angles have equal measure. Conclusion, the angles are congruent. So the converse, we're going to switch the two parts. If two angles are congruent, so you have to be specific. And I'm going to use the symbol here. Then they have equal measure. I'm looking at the true or false. If two angles have equal measure, then the angles are congruent. This one is true. I'm looking at the converse. If two angles are congruent, then they have equal measure. This is also true. So we can rewrite as a biconditional. And remember, to do that, you're going to cancel out the if, cancel out the then, and replace the then with if and only if. So two angles have equal measure if and only if the angles are congruent. For a biconditional statement, it combines two if-then statements into a biconditional using the words if and only if. So remember that a conditional is one that is written with an arrow, if P then Q. The converse is if Q then P, and it puts them together using a double arrow, P if and only if Q. So here we're trying to break it apart the other way. What are the two conditionals that form this biconditional? So when you're looking at it, when we just did the other part, we took out the if, we took out the then, and replaced it with if and only if. Excuse me. So what we're going to do is we're going to take out the if and only if, replace it with then, and we're going to put an if at the beginning and make sure it makes sense. So one of the statements is, if a ray is an angle bisector, then it divides an angle into two congruent angles. The other one we're going to do the converse of. So we're going to start with the if and only if, we're going to replace it with if. So if the ray, be specific on this part, divides an angle into two congruent angles, then it is an angle bisector. So make sure that if you're flipping it around and it has the word it in there, you do have to be specific with that if it's written first. What are the two conditionals that form this biconditional? Two numbers are reciprocals if and only if. So you're looking for that if and only if part. Their product is 1. So the first one, you're just going to put if at the beginning and replace if and only if with then. This one is the easier of the two. If two numbers are reciprocals, then their product is 1. The other one, you're going to switch them around. This becomes your if, this becomes your then. So if the product of two numbers, be specific on that part, is 1, then the numbers are reciprocals. The next part of it is a good definition. So what you're going to have to do is read the definitions and classify them as a good definition or not, and then give reasons why. Good definition is a statement that can help you identify or classify an object. The components of a good definition, uses clearly understood terms. They're very specific, it's very precise, and it is reversible. So we want to decide if this definition is reversible. So a quadrilateral is a polygon with 4 sides. So first of all, this one is written as a statement. You have to write it as a conditional first. So if the polygon is a quadrilateral, then it has 4 sides. So the converse will switch it around. We're going to put if where the then is. If a figure has 4 sides, then the polygon is a quadrilateral. So we have to decide if both of them are true. So if the polygon is a quad, then it has 4 sides. That's true. If the figure has 4 sides, then it's a quad. That is also true. And we can write it as a biconditional. Remember, you take the initial conditional. You're going to cancel out the if. So we're going to start out with the polygon is a quad if and only if, this is the part you're adding, it has 4 sides. So you put them together by taking out the if and the then, and you replace the then part with if and only if. Just about the last one. A straight angle is an angle that measures 180 degrees. So looking at this one in the book, you first write it as a conditional. Oops, sorry. Step 1, rewrite as conditional. Step 2, write the converse. Step 3, are they both true? Step 4, write biconditional. Okay, so one way to show that a statement is not a good definition is to find a counterexample. So we want to point out which one of these is a good definition. So let's read through them all. A fish is an animal that swims. Well, that one is kind of vague because there's many things that swim that are not fish. So we would have to come up with one of them that isn't. Maybe dolphin. Rectangles have 4 corners. Well, there's other things that have 4 corners, so it's not very specific. How about a square? Giraffes are animals with very long necks. It's not very specific because of this very long part. Maybe an ostrich. They have kind of long necks too. So how definite is very long? And a penny is a coin worth 1 cent. So this one right here is the most specific, and it is reversible. So if you talk about a coin being worth 1 cent, we all know that it has to do with a penny. So D is the only one that works here. A square is a figure with 4 right angles. This is a true statement, but when you switch it around, if the figure has 4 angles, then it's a square. What about a rectangle? So we're going to say no, rectangle, not reversible. How can you rewrite the statement, obtuse angles have greater measures than acute angles? With this one, it's kind of a vague thing. Sometimes when you rewrite, you don't even use all the words. So maybe just define what obtuse angles are. Obtuse angles are angles greater than 90 but less than 180. So you don't always use all of the words. This time we cut that part out. So today we learned about biconditionals, how you have to first write the conditional, then write the converse, determine if they're both true and false, true or false. If they're both true, you can write a biconditional. To do that, you take out the if, take out the then, replace the then with if and only if. The last part determined what a good definition is, and going back to just review what that is. It's clearly understood terms, it's precise, and it's reversible.